Okay, these are like the first 8 that we did actually in class that are part of the homework, and there's going to be 8 like them out of 20 on the test. They're just doing these again, right? Which should be pretty easy. Should be 40 points right there. So here's a triangle, a right triangle with 2 sides filled in. How do I find the third side? Pythagorean theorem, right? So that is the square root of 13 squared minus 12 squared, which is 5. Right? That's a common Pythagorean triple. Okay, now with all that filled in, what is the sine of theta? Opposite over hypotenuse, 5 over 13. What is the cosine of theta? 12 over 13. Right? You know, that's not even like chapter 5. That's like chapter 4 stuff. But we use these when we start doing the double angles. Sine theta and cosine theta are part of the formulas, right? So we've already got them done. I rewrote them up here. What is the formula for the sine of 2 theta? Right. It's sine of 2 theta is 2 sine theta cosine theta. Well, we already did that, right? We got the sine of theta is right there. 2 times 5 over 13 times 12 over 13, which is 2 times 5 times 12, 120. What's the denominator? 13 times 13, 169. So there's that. 120 over 169. Okay, cosine of 2 theta. Right, what were our formulas for the cosine of 2 theta? That was our next slide. You know, you could use it. You could use any one. You know, take your pick. I'm going to use the first one for calculations. I think this one is just as easy. Otherwise, you got to find common denominator between these two. But if you use the sine and cosine, they actually already have the same denominator, so no problem. So let's do that. That'll be cosine squared of theta minus sine squared of theta, right? But the cosine, we already calculated this. That's 12 over 13 squared. And the sine of theta, we already calculated is 5 over 13 squared. So 144 over 169 minus 25 over 169, which is 119 over 169.